So it is so awesome to have Mark Jessel with us today. Mark is a professor and West Australian Fellow at the Centre for Exploration Targeting at UWA, and he's also the lead researcher of the WAXI program, which he'll be chatting with us about with his key learnings from 15 years of the West African Exploration Initiative and future plans. So it is going to be awesome hearing about this. I hope you all enjoy it. Please use the chat. We'll all have the chance to jump off mute and we'll open up the floor at the end. And thank you so much, Mark, for joining. It's just wonderful having you.
Thank you. Welcome everybody. Thanks for coming along. This talk is, in a way, unintentionally a part B to a talk that Adama Sidibe gave a few weeks ago, who was talking about all the different mineral deposits in West Africa. And thanks to him, I don't have to go through all of those different deposits again, although I will show a couple of slides of maps, but not of the deposits themselves. So I'm going to be talking about a project that's very dear to my heart that's been running for 15 years now, as the title suggests. It's called the West African Exploration Initiative. It's a project, as you'll see, that's funded by industry and government and organized by Amara. So what I'm going to talk about is this bit of geology. So in case you're not particularly familiar with West African geology, this is the 1-minute slide on getting you up to speed. The area that's the West African Craton is outlined in black, more or less, and the dark red color and the purple in this map show the Archean areas. We have Paleoproterozoic sitting adjacent to that. We have Mesoproterozoic and Younger basins sitting on top of both of these. And then we have Pan-African remobilized craton margins. And so that's the summary of the geology. And most of the talk, I'm going to be talking about the southern half of the craton, but a lot of the same logic applies to the whole area. And as this paper by Goldfarb in 2017 pointed out, West Africa is currently the world's premier Paleoproterozoic gold province. Even though it's not dominating total gold production, it's been increasing steadily over the last 20-25 years or so, and represents a zone where there's been continual exploration and happily continual discovery over that period of time. And this is not news to Mansa Musa, who about 800 years ago became the richest man in the world by happening to be the king of a kingdom that was more or less centered over Mali, extending into neighboring countries. And this picture of him highlights the fact that he can walk around with a gold crown and sit down and pick up a gold sphere as well. He was fabulously wealthy due to the enormous amounts of gold that could be found in that region. And in terms of understanding where all of these deposits are, the first work that really brought this all together goes back a century now by Henri Hubert, who produced this map of the different mineral occurrences across West Africa, not just gold. And it's important to remember that in West Africa, we have gold, but also uranium, we have iron, we have bauxite, we have diamonds, all sorts of other interesting things, and much more to come, I'm sure. But we can see it covers the whole of that southern part of the craton. And in addition to looking at the mineralization, there was also extensive mapping going on. This is a map from over 100 years ago of the southern part of the Ashanti Belt in Ghana. And a bit later, the same Henri Hubert, who made the mineral deposit map, produced the first geological map of the whole of the southern part of the West African craton. And if you squint your eyes, it more or less hasn't changed since then. So it makes you wonder what we've been doing for the last 100 years. But let's not worry about that. Let's go into more detail but just to say that he did an amazing job with his colleagues of putting together this first synthesis of the geology. But there's some challenges to working in West Africa, and the first of those challenges is that everybody speaks a different language. So this is a map of the different languages, the administrative languages in West Africa in the southern part of the Craton. And you can see there's Arabic, there's French, there's English, there's Portuguese. And every single country in the region has at least one neighbor that speaks a different language. So harmonization of data sets is a challenge. They've got very different geological survey capabilities across the region. They've got very different geology. And so bringing together all of this data to try and understand things at the larger scale is one of the challenges. And if you think this is a purely colonial problem, let's have a look at the maps of the local language. You can see that regardless of what type of language you speak, there's still going to be significant challenges in putting together our understanding of the region. So there's a very fragmented regional understanding of the geology. We look at the, excuse me, the higher education challenge. Geological departments across West Africa have got significant numbers of people wanting to study earth science. If you look at Burkina Faso and Senegal, they're up into the multiple thousands of students at any one time studying earth science. So you can see the pressure on those universities just to get the teaching done, let alone to try and do any research, is quite significant. And having the time to supervise graduate students is a challenge as well. And then we look at the number of staff that are available to do all of this work, and you wonder how they do anything at all. It's just incredibly impressive. So the universities are, if you think it's bad in Australia, go to West Africa. So one of the underlying logics to the WAXI program before we get into the outcomes is to think about it in terms of what the relationship is between a mining company and an international mining company and a country, a developing country, such as those we find in West Africa, or in this case, in Suriname in South America. So the basic logic of the relationship is that the country hosts the resource and has initially all of the rights to that resource. Some international company wants to come in and to extinguish the resource, and by extinguish, I mean in this case, dig it out of the ground and take it away. Because once, of course, it's been taken away, you can't use it again, and the country's lost that resource. And so the logic of the relationship is that the country needs to be compensated by mining rents, taxes, and employment. And the country has to decide whether the short-term gains from these things, which it can then use to build hospitals and roads and so on and so forth, and schools, whether the short-term benefit from these rents outweighs the loss of the resource. But as a researcher working in these regions, we have a fairly similar relationship. We have a country that hosts a scientific problem. So we want to understand, for example, what the age of a granite is. This is an interesting question, and we happen to have the equipment that's necessary to solve this question, which probably doesn't exist in West Africa. And so in order to be welcomed into the country, the universities, the geological surveys, need to be compensated by involvement in the research, which provides the access to the funds, and by developing the research capacity so that in the future, this type of work can be done. Because once you've worked out the age of the granite, there's really not much more to be said. And so that question in a simplistic sense has been solved. So you can see that the moral imperative for mining companies and for researchers is actually not all that different in these cases. And what perhaps is different is the size of the hole that we're talking about. So we started the WAXI program 15 years ago as a collaboration between 4 universities, 2 in Africa and 2 outside Africa. as well as with the geological surveys, and it was run as an AMARA project since the beginning. And you can see from some of the numbers that we're showing here, it's produced a lot of publications on the geology of West Africa. It's trained a significant number of students and postdocs, and that work is continuing with Agate, as I'll talk about in a minute. There's been a huge number of partners, and the partners fall into three main types. I'm talking about organizational partners now. There's the industry sponsors that sponsor these AMARA projects. There are in-kind sponsors, which are the local geological surveys that supply infrastructure, support, that supply access to data, and supply their knowledge of the geology. And there's the research and development partners, which are the universities in Africa or overseas. And so all of these different groups are working together to try and answer some big questions about the geology of West Africa. And today, I'm just going to pick out 4 themes that we've been working on for those 15 years. They're not the only things we've worked on, but they're certainly interesting themes. And the reason I've highlighted these ones is because they're really the questions that we're going to try and answer in the next few years, in the next stage of the project. So the first part of the WAXI program is the continued support for professional research by training scholarships and high-end workshops, and I'll talk about that in a minute. The second theme is looking at belt and craton scale architecture and inheritance. Third scheme is looking at transgenerational mineral systems, and the fourth theme is understanding the tectonic setting of the formation and evolution of the West African craton. So in terms of supporting research in West Africa, you can see the numbers with over 100 master's, PhD, and postdoc projects, of which more than 2/3 are African students or researchers. And the map in the top right is showing the dots showing where these research projects are carried out. And probably the most important thing here is the yellow stars, which show those locations where universities have taken on WAXI's trained students and hired them to become the next generation of researchers across West Africa. So in terms of training, apart from these PhD, master's, honors projects, we also run training courses, typically 2 or 3 a year, in person. Of course, the last couple of years has kind of hit us on the head with that, so we haven't been able to do that the last couple of years, but we're just getting started again. And these are courses that are attended by students, by company personnel, by geological survey personnel. This particular one was in Abidjan in Côte d'Ivoire a couple of years ago, probably one of the last ones that we ran before COVID. And so this idea of capacity building and sustainability of the research, which was underpinned by the capacity building, started off in 2006. And in the beginning, it was the IRD, the Institut de Recherche pour le Développement, which I used to work for, in Toulouse, which was in charge of the capacity building. But we wanted to get some sort of level of independence from the research project. So we worked with an NGO based in Luxembourg for the next phase of the project. And then in the most recent phase of the WAXI project, we actually wrote into the proposal that we were going to set up in the longer term, an independent, not-for-profit to support the capacity building work so that it could continue even when the cycles of research funding weren't available. And so we set up a project a company called the Agate Project, which is a charity registered in Australia. And since, for the last couple of years, we've taken on the role of the capacity building work that's under the WAXI umbrella. And we'll talk about that. These are some of the people who have been awarded PhD, master's funds, as well as early career researchers that have been provided with funding to go on. And if you're on LinkedIn, you may have seen me spamming you with the latest set of awardees over the last few weeks. And this, as I said, this work is all being supported now by the AGATE project. If we move on to the research side of it, WACC was from the beginning designed to be a multi-scale program. And the reason for that is because companies are very good at pulling apart their own deposits. They're very good at the very small scale work. They do some work on the belt scale, but integrating all the way up to the craton scale is really beyond the scope of the explorers in West Africa. So that's one of the levels of research that we've really been able to add value to. Trying to understand the crustal and belt scale architecture, of course, you can't really understand structure if you don't understand stratigraphy. And so over the course of the WACC project, we've been developing a harmonized stratigraphy across the whole region. Here you can see just the work of Nicolas Mériot, a PhD student, who produced this harmonized stratigraphy for Côte d'Ivoire, but it extends across the whole region with the work of James Davis. We've also collected some new geophysical data. This is an MT survey we carried out between Burkina Faso and Ghana. And the important things that we were able to pull out of this magnetic telluric survey, the first thing was that the structures that we could see at the surface that would be mapping based on our field work and our interpretation of magnetics and radiometrics and gravity, is that these structures that we could see on the surface were major electrical structures at depth, and their depth extent, in this case, this cross-section here is going down 300 kilometers. So we're seeing these are major structures that are coming through. And the second thing was that, if I put these dashed lines on, we can see that there's a major change, a major step in the thickness of the lithosphere. Why? Who knows? This is work for the future. But there's an observable step in the lithosphere thickness. This is from a paper by Florian Lepape from Dublin. And we can see that there's something like 50 kilometers step in the lithosphere. And this is occurring more or less coincident with one of those major structures that we've mapped at the surface. So what we're seeing at the surface is translating into very, very deep features in the Earth. We've also carried out gravity and magnetic inversions of different types. On the left, we have a series of 26 gravity and magnetic inversions, joint inversions were carried out by Louis Gallardo for the whole of Burkina Faso, so quite an undertaking. And on the right-hand side, we have a gravity inversion for Southwest Ghana. So these have, again, these help to fill in the intermediate scales between these very deep features that we can see in the magnetic tellurics, the somewhat shallower features we can see in the gravity and magnetics, and the surface geology that we're mapping out in the field. We put all of these data sets together into a number of 3D models. In this case, the lower left is a model by Stefan Peruti for Southwest Ghana, for the Ashanti region. Lower right is a 3D model of the whole of the southern part of the Craton. And at the top right, we have a 3D model that goes all the way down into the mantle, showing the relationship between the surface structures. And of course, there's much smoother, less well-defined, deeper features. And so the idea of these 3D models was to provide context for the mineralization. There's a number of papers looking at that. But geophysics isn't the only way of seeing deep these days. And so there's been a systematic program of collection of geochronology, but also lutetium hafnium data. The yellow circles in this map are of the gold deposits, and the colors underneath relate to the epsilon hafnium values. Essentially, you can read this with the hotter, redder colors representing the parts of the Paleoproterozoic that are sourcing felsic plutons that have come from Archean sources, whereas the paler blue are sourcing juvenile lithosphere and crust. And we can see that there's a pretty good correlation in the Birimian part of the sequence between the more juvenile parts of the system and gold mineralization. But even though the majority of the deformation in West Africa finished about 2 billion years ago, we've been starting to get sniffs of reactivation structures, and that's something we certainly want to look at in the next few years in West Africa. This is on the left-hand side is a map of Ghana with two of the major shear zones, the Kateso shear zone and the Boli-Ngondi shear zone. And in the top, the work of Abigail Ayekwe, who's shown that the seismic data that we can get out from the Volta Basin, which is the eastern part of Ghana, is showing that some of the Kateso shear zone, which is clearly mappable at the surface in the Birimian structures, is actually reactivated and is offsetting the basin sediments. And then if we go even younger, there's the fission track work from Fernie et al. Showing that the Boli-Ngondi shear zone was probably reactivated in the during the opening of the Atlantic, so much more recently again. Again, it helps these sorts of reactivation structure studies help us to identify those weaknesses in the crust and the lithosphere that are likely to be of major significance for mineralization. And there's also, of course, the Pan-African remobilization. On the left, we have the newly flown radiometric survey for Sierra Leone. We can see where that arrow is showing, highlighting clearly the remobilization during the Pan-African. And on the right-hand side, we have the map of the mafic dikes. And some of the mafic dikes are Mesoproterozoic, but they go all the way up to the opening of the Atlantic and fill in most of that time space in between. So there's a continuous story of mafic intrusions throughout the region, even though the craton itself became more or less passive at about 2 billion years ago. So if we go to mineral deposits now, this is an image from a paper that's just come out from Quentin Mazurel, looking at the timing of deposits across West Africa. And this is a theme that's going to come up again and again, is that we can see that the older deposits are in the east, so the pale blue and the brown deposits are in the east, and the younger, yellower deposits are in the west. And just to highlight that all of the deposits that have a red rectangle around them are those deposits where we've published individual studies on these deposits. So we've got a pretty good coverage. We haven't obviously visited all the deposits, but we've got a good geographic and temporal coverage of the region for the Paleoproterozoic part. And of course, there's not just a time division, there's a spatial division in the types of deposits. We can see that the basin orogenic deposits are mostly in the Far East and the Far West. The post-collision deposits are mostly in Senegal and Western Mali, up in the far northwest of the region. And we can look at that also again back in a time space diagram where we're looking at the earlier orogenic deposits followed by the later intrusion-related and atypical orogenic deep gold formation in this region, which then those two groups dominate most of the gold production currently, with the exception, of course, of Taka, which is a paleoplacer, as we heard about a few weeks ago. So we've put all of this together in order to try and understand the tectonic evolution of West Africa. And the first thing that we did, apart from putting together a very large GIS database based on our data harmonized with all the previous work, and once we had that, we started to attribute ages to as many of the different types of data as possible and integrated them into what we're calling a geodynamic atlas that shows a 200 million year evolution of West Africa from 2.2 billion years to 2 billion years. showing, and again, this is highlighted not only in the mineralization, but also in the felsic intrusions, in the deformation, in the metamorphic studies, and in the formation of sedimentary and volcanic sequences, is that there really is a significant east to west migration of activity across the craton. And if you calculate it, it's something like a 50 million year diachronous behavior, which over 200 million years or 150 million years translates to something like 3 centimeters a year of evolution of this magmatic tectonic mineralization front from east to west. And it's not to say that it's perfect, and it's certainly worth noting that throughout most of the history, Western Senegal in the northwest part of the map is active. And so Senegal is this sort of outlier of activity from the very beginning, which is independent of the migration east to west that we see across this whole area. So we've got this static view of what the geology looked like over a 200 million year period. And rather than just trying to fit it to one tectonic model, we've come up with a number of different models, and we held a workshop in the south of France. And yes, sometimes it's really hard to be a geologist. And we came up with deliberately not just one scenario, but 3 scenarios that we could compare. And so the first scenario is a subcretion scenario, where there's essentially failed subduction zones occurring across the region. The second scenario is a model proposed by Graham Begg, where we have a rigid lithosphere, a pre-existing rigid lithosphere that's controlling the evolution. And the third model is a more or less modernish plate tectonics model. And so if we look at the subcretion model, the idea here is that there's a mantle wind which is driving the plate tectonics. It's not driven by the subduction itself, but the subduction, because of the higher heat flow, is essentially failing to create full subduction zones. And so each arc, each belt that we see in West Africa represents one episode of failed subduction. So that's the first model. The second model, as proposed by Graham Begg and the other people in that group, is a model where these blue lithospheric blocks they're all Archean, they're pre-existing. So whatever's happening in the Birimian is happening essentially in the gaps between these Archean blocks, which are believed to be essentially rigid. That doesn't mean that there aren't subduction zones, and we can see the subduction zones in this animation here. They're the ones driving the deformation, but the local subdivisions in tectonics and in tectonic evolution are driven by the pre-existing structures in this area. And then finally, we have a model developed in G-plates that was produced by Helen McFarlane, which essentially takes a modern view to the evolution of the region, with a series of arcs coming in, with some transform faults breaking up the different regions, and with finally that big purple block of Archean coming in and acting as an indenter into Guinea and into Cote d'Ivoire, into Ivory Coast at the very end of the story. So we have these 3 different models, and of course, it's worth noting that West Africa wasn't alone. Well, actually, that's a really good question. Was it alone? And if we go to the next slide, here's a series of reconstructions of West Africa. In the top, the West Africa is that yellow and red turtle-shaped object. A series of different plate reconstructions for somewhere between 2.2 and 2 billion years ago. They're all different. In the lower left, there's an image that's used in many exploration companies' websites to demonstrate that their deposit coincides with either what's going on over on the West African Craton or in the Guiana Shield on the other side. And then finally, another model produced by the G-Plates group itself in an honours thesis. And what you can see is that the details of what was in the neighbourhood of what are very different for these different models. And perhaps the most sensible thing we can say is that we actually don't have enough data. So one of the things that we'll be looking to do in the future is to start a project that looks at trying to integrate the data sets that we have in West Africa with the ones that we have in South America. So just to summarize, these are the major themes that we're working on that we're particularly interested in at the moment. Continued dedication to capacity building via scholarships for research and for students and professional training, conferences, those sorts of things. But as well, a theme on trying to understand the belt scale and craton scale architecture and the inheritance of structures from earlier on. Study of the transgenerational mineral systems, the role of the Archean in the Birimian, the role of the Pan-African reworking, what the basins are doing. And of course, an understanding of just what the tectonics really looked like at the time. And I talked about all of these different things, and I've mentioned some of the names of some of the people whose papers came out, but of course a project like this is quite large. And this is the sponsors meeting from 4 years ago now, where one of the last ones, the last but one, where we were allowed to meet face to face. And you can see there's a huge enthusiasm for this type of project because it's bringing together people who all managed to get something out of it. The researchers are getting access to funds to collect new data. The companies are getting access to that data, and the geological surveys are getting all of the data that we collect to integrate into their own data sets, as well as having access to the training. So just to finish up, just when you thought it was safe, we started up a project a couple of years ago, 3 or 4 years ago now, in South America, in the Guiana Shield, which is why we're confident that we can have something to say about the relationship between these two blocks. And to understand the Guiana Shield, you need to understand that there's even more languages between the different countries. The 5 major countries each speak a different organizational language. There's much more water than in West Africa. There's much less outcrop and there's much less known. So that's a really entertaining research project too that can be the topic of another talk in the future. But for that, now I'd like to thank all of you for listening. I'd like to thank all of our sponsors, all of the researchers. I thank Amara for helping us get this done over the last 15 years. And I'm more than happy to answer questions.
Thank you so much. That was it's amazing what you've done. Well done.